So, welcome back. We have been looking at epistemic logic and we have seen a very simple case of epistemic logic, which was a propositional logic plus this modal operator called K essentially. And we have seen what the language is like, and we have also seen what are the set of axioms that can go along in the proof system, that what is it that you assume to be true about knowledge when agents know about knowledge essentially. So, let us talk about this semantics now. This is Saul Kripke almost 200 years ago, 80 years ago, defined the semantics of epistemic logics, in which different agents operate with incomplete knowledge and as a consequence are unable to know the real state of affairs. So, in typical world situations, you know some things and you do not know some things, and other agents know some things and other agents also do not know something. How does one reason with this kind of partial knowledge essentially? Remember that it is still knowledge, we are not talking about belief, we are not saying that you can know something which is false. You can know only something which is true, but your knowledge is incomplete. You may know some things, but you may not know other things. So, Kripke introduced this notion of possible worlds. So, it is imagine that there are many possible worlds and each agent can access only some of them, or all of them also, if as the case might be, but in general only some of them. Such models are known as Kripke structures, in which different possible worlds have different sets of propositions that are true essentially. So, if there are 3 propositions, let us say in the world P, Q and R, you can imagine that there are 8 possible worlds, for each combination of P, Q, R being true or false essentially. And different agents may know about different possible worlds. Of course, when in a real situation, one of those possible worlds will be the real world essentially. But even in the real world, there may be some incompleteness in the knowledge about those agents essentially, as we will see. So, agents do not know enough to be able to distinguish between some possible worlds and others, even though the ground truth holds in exactly one of the possible worlds. In such a scenario, and we will see examples that will make it clear, we will see what is this notion of this possible worlds. So, these things are called Kripke structures. So, let S be a set of states or of possible worlds essentially. What is a possible world? A possible world is one in which some statements are going to be true and some statements are not going to be true. Let phi be a set of atomic propositions. Let pi be a mapping or truth assignment to those atomic sentences. So, it maps the set phi onto true or false. It is an interpretation, like we said when we were looking at propositional logic, function that assigns a truth value for each proposition in phi, and it does so for each state belonging to the set of possible states or set of possible worlds. So, this is a truth assignment or an interpretation. Let A be the set of agents. Then for each agent A, we define a binary relation labeled by A, R of A, be a binary relation on S cross S. So, it is basically an edge between different states in the possible world structure. This relation is an equivalence relation and is often used to model that the agent cannot distinguish. Then a Kripke structure M for n agents is a tuple where there is a set of states, an interpretation function and a set of binary relations for each agent, each of the agents I think. So, let us talk about entailment, and we will assume that we are always talking with respect to one of those possible worlds, and let us call that world S. So, given the Kripke structure and given one state S in that structure, we say that a sentence P is entailed if the interpretation function for that statement in that state gives you a value of true. So, it is simply saying that the interpretation tells you that it is true in that particular state, and this truth value of P is only in that state essentially. So, this is talking about facts essentially, what we call as objective statements when we were talking about auto-epistemic logic. And then of course, there are the logical connectives. A formula like phi and phi prime is true if phi is true and if phi prime is true. A negation is true if its negation is not true. Most importantly, we say that an agent I knows that phi is true. So, this is a formula in our language, and this formula k I phi, which stands for the fact that agent I knows phi, this formula will be true if first of all it should be true of course in phi should be true in the state S, but not only that, but in every state T such that S T belongs to the relation R I for the agent I, this formula must be true. So, what is this saying? This is saying that let us say there is this state S and in this P is true, and there is another state R in which also P is true, and there is a third state let us say Q, and in also this P is true. Then because in all the states that are as we say reachable from S, P is true, then agent I. So, this is should be labeled by the agent number. So, let us say if the agent is I, then these edges are labeled with agent I. If every state reachable via this name of the agent I, this is true, then we say that P is true essentially. But if we added another state, let us call it T, in which not P is true, then we cannot say that agent A knows P, agent I knows P, because there is a possible world in which P is not true. So, agent I knows a formula phi only if it is true in all possible worlds that the agent cannot distinguish between. So, here is an example, and that hopefully should make things clear. So, we have this Kripke structure. We have 3 states S, T and U. Then we have 2 agents 1 and 2. We have only one formula in our these things, and we have 2 relations R 1 and R 2 for each of the 2 agents as to which worlds they cannot distinguish between essentially. And we have the truth assignment that there is only one formula P. So, in state S it is true, in state U it is true, and in state T it is not true. We can depict this graphically as follows, that we have these 3 states T, S and U, which are the labels in the nodes. Then we have these edges between states. So, first of all notice that every state has a reflexive edge for each agent. That means that it is not the case that the agent cannot distinguish between that state and itself. So, we have 2 edges here, one is labeled 1. This means that agent 1 cannot distinguish between the possible world T and the possible world S. And there is another edge which is labeled 2, which says that agent 2 cannot distinguish between the possible world S and the possible world U. Now, you can see that in T, as we said, P is not true, but in the other two states P is true. So, what can we say here? We know that, and we are going to be talking with respect to this state S all the time. So, in this state S, given this Kripke structure, it is not true that agent 1 knows P, and why is that? That is because in state S, of course, P is true, as you can see, but there is a world that agent 1 cannot distinguish from, which is the world of which is a world labeled T. So, agent 1 cannot distinguish between S and T. Now, in S it is true, P is true, in T it is not true. So, clearly agent 1 does not know that P is true essentially. But agent 2 knows that P is true, and why is that? Because the possible world for agent 2 is S and U, and in both S and U the statement P is true. So, as far as agent 2 is concerned, in whatever world it can imagine, P is true. Now, again remember that we are always talking with respect to the state S. Now, agent 1 knows that agent 2 knows P or agent 2 knows not P, which means agent 2 knows the truth value of P. So, this statement is saying that agent 1 knows that agent 2 knows the truth value of P. See, agent 1 himself cannot believe that P is true, because as we have said, he cannot say that P is true. So, he of course, he also does not know whether P is false or whatever the case. P is not false in this example, except if we were talking about the world T, then agent 2 would think that P is false. So, in S, that is our reference state that we are talking about, agent 2 knows the value of P, which is represented by the fact this disjunction that agent 2 knows that P or agent 2 knows not P. So, it knows what is the value of P. Now, this is true because in the state S itself, which is what our reference state is, agent 2 knows that P is true. We have already observed that. So, the disjunction will be true naturally. Likewise, in state T is the world which agent 1 cannot distinguish between. So, what agent 1 is seeing is that in state S, agent 2 knows that P is true, and in state T, agent 2 knows that P is not true. This is in state T, because in that state P is not true, and from that state agent 2 cannot access any other state essentially. So, it knows that P is not true. So, again it knows that P is not true. So, the disjunction becomes true again, because it knows one of the components, and since both are the case, then agent 2 knows whether P is true, whether the agent 2 is in state S or state T, which are the two states that agent 1 can see, and hence this formula is true. So, we will leave this as a small exercise for you. You can think of it as saying that agent 2 considers it possible that agent 1 knows the value of P, but you should convince yourself that it is indeed the case. So, you have to go through the argument in a little bit more detail. Let us take another example with a small pack of cards. Let us say there are 3 players, Anne, Bob and Kathy, represented by A, B and C, and we have a small pack of cards of 3 cards in fact, whose names are 1, 2 and 3. Let the atomic proposition that a player is holding a card be represented by card superscript player. So, that 2B for example says that card 2 is held by player B, which is Bob. So, the following are sentences in this world, in this domain. The first one says agent A knows that B is holding 2, Bob is holding 2. This is the intended meaning of the sentence. This one says that agent A knows that A is holding 0 or A is holding 1 or A is holding 2. So, this is the or is across. Agent A knows that A is holding 1 or agent A knows that A is holding 1 or agent A knows that A is holding 2. So, for each of the 3 cases 0, 1 and 2, agent A knows what agent A is holding essentially. So, Annie knows her card, that is all. Agent Annie does not know, Annie knows that Bob does not hold 2 essentially. That would be the case if Annie was holding 1, then or sorry, if Annie was holding 2, then Annie would know that Bob is not holding 2. But this is how you would say that Annie knows that Bob does not hold 2. So, to be means Bob is holding 2B and not to be is that Bob is not holding 2. Bob knows that Annie does not know that Bob holds 2. This part says that Annie does not know that Bob holds 2 and Bob knows this. Annie does not know that Bob does not hold 2. So, the second part says does not hold 2, Bob does not hold 2, and the first part says Annie does not know this. So, the last statement is also considered equivalent to saying that Annie considers it possible that Bob holds 2, because she does not know that Bob does not hold 2. So, it could be possible that he is holding 2, and we sometimes write it in a short form by putting K hat instead of K and saying that Annie considers it possible that Bob holds 2. So, let us say Anne and Bob pick 2 cards, Annie gets 0 and Bob gets 1, and from this pack 0, 1, 2. So, this is the as shown here in this rectangle the situation. The first card is for Annie, the second card is for Bob, and the third card in this case is on the table. So, Annie gets 1, 0, Bob gets 1 and card 2 is on the table. This is how the world would look like. As you can see here, Annie is holding 0, that is the real world shown in the dark rectangle. But Annie does not know whether Bob is holding 2 or Bob is holding 1, and therefore, there is an edge between these 2 states labeled with Annie, that she cannot distinguish between the fact that whether Bob is holding 1 or whether Bob is holding 2 and the other card is on the table. Likewise, Bob cannot distinguish between the fact whether Annie is holding 0 or whether Annie is holding 2, and in so on. You can see that from each of these states there is the indistinguishability relation. So, in this state which we have labeled as 0, 1, 2, what can we say? Bob does not consider it possible that Annie has card 1. Remember that this part says, this hat is not very clear here, but you can imagine the hat is there, just watch that carefully. The part I have circled says that Bob considers it possible that Annie holds 1, and when you put a negation, it means Bob does not consider it possible. You can imagine that is true because Bob is holding 1. Annie considers it possible that Bob considers it possible that Annie holds 1. See, Annie is holding 0. She does not know whether Bob is holding 1 or 2. If Bob were to be holding 2, then Bob would consider it possible that Annie was holding 1, and this is what this statement is saying, that Annie considers it possible that Bob considers it possible that she has the card 1, because Annie does not know that Bob is actually the one who is holding 1. Then Annie knows that Bob considers it possible that Annie holds 0 essentially. So, she is actually holding 0. So, it must clearly be possible for Bob to consider it possible that she is holding it 0. So, let us say Kathy also picks a card, which is the third card. So, now we have this world in which everybody is holding a card, and then again there is the indistinguishability relation between the different agents. Again 0, 1, 2 is a real world. Anne is holding 0, Bob has got 1 and Kathy has got 2. In this world, what does this say? KC, OC, KC 1C, KC 2C means Kathy knows that she is holding 0, or Kathy knows that she is holding 1, or Kathy knows that she is holding 2, which means that she knows what she is holding, and both Anne and Bob know this. So, Anne knows that Bob knows that Kathy knows her own card. So, Anne knows that Bob knows that Kathy knows her own card. Now, Anne is holding 0. So, that is a true statement, because you can check that in this given state that is true, and Anne considers it possible that Bob considers it possible that Kathy knows that Bob is not holding 0. Anne is not holding 0. So, Anne considers it possible that Bob considers it possible. So, Anne does not know what Bob is holding. So, Bob could be holding 2 or Bob could be holding 0, Bob could be holding 1. So, in either case, it is possible that Kathy would think that you are not holding A, Anne is not holding 0. Anne has card 0, that is the first part, but she considered it possible that Bob considers it possible that Kathy knows that Anne does not have card 0, which is not the case because she is holding the card 0, but there are 2 considers it possible in the row. So, you should think about that. Okay. So, let us take a break and then we will talk a little bit about what actions can do in epistemic logic.